So the union rule for sets, also known as the addition rule for sets, states that the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersect B. This is a rule that has to do with how many elements are actually in our set. And the fact of the matter is, if we take a look at our Venn diagram, we can see that this actually makes perfect sense. Because if we look at A, we count up all the elements in A, that's going to be everything that's in this circle. And if we count up all of the elements in B, that's going to be everything in this circle. But hopefully what you recognize is that the stuff in this circle, this area, which we know as A intersect B, that has been counted twice. Once when we counted it as part of A, and the second time when we counted it as part of B. And so we need to do this step over here and subtract it from the sum of the two sets. So let's take a look at a simple example. Let's say that we know that there are 10 elements in A, there are 12 elements in B, and there are 2 elements in their intersection. So the question then becomes, how many elements are there in the union? Well, we can just simply use the math that we have to say, okay, it's going to have to be 10 plus 12 minus 2, which is 22 minus 2, which is just 20. But let's go ahead and take a look at our picture to understand why exactly this is happening. So first of all, we're going to work backwards. We're going to look at how many elements there are in A intersect B. And there are 2 elements, so I'm going to put my 2 elements in here. Now, moving a step up, it says that there are 12 elements in set B, but if we look at our circle here, I've already counted 2 of the elements from set B, which means there are only 10 left in this area of B, which does not include the intersection. Next, we take a look at the number of elements in A. There are 10 elements in A, but as we see, we've already counted 2 of them, which leaves over 8 elements to be in this part of A that's not part of the intersection. And so when I go ahead and I add up 8 plus 2 plus 10, because that's the union, I get my 20 elements. One more thing I should mention is that every once in a while you will end up with a problem that will give you, let's say, the union, the number of elements in A and the number of elements in B, but is missing the intersection. And the fact of the matter is, as long as you're given 3 of those 4 variables, you can always find the last one. So for example, if we needed to find the intersection, we could always add it to both sides and bring the union over, which would give us the number of elements in A intersect B is the number of elements in A plus the number of elements in B minus the number of elements in the union. So really, you can find any one of these quantities as long as you have the 3 other ones given to you.